Good evening.
Good
Am I
evening.
audible?
Yeah.
Any doubt from last class?
No, sir.
Okay. So let me define you these two different types of oscillation on the basis of surrounding viscous medium. First one was undamped oscillation. The oscillation in non-viscous medium so that amplitude of oscillating body remains same. That is called undamped oscillation. But if oscillation is in any viscous medium, the oscillation of a body in viscous medium so that amplitude decreases with time. Is called damped oscillation. Now, in this damped oscillation, if you have to somehow manages to keep its amplitude constant, so we must have to supply some external agency. Suppose there is a bob which is oscillating in viscous medium, so its amplitude will decrease exponentially with respect to time. So to keep amplitude of this particular part to be constant, so you must have to supply some external source to it. So let's say external oscillator is connected to this part in the form of tuning fork, which may vibrate to and fro and causes to vibrate this particular bob with respect to it. This particular oscillation, which is done under the action of any external agency, is called forced oscillation. So in damped oscillation, if it is driven by any external agency, that is called forced oscillation. So to keep amplitude of damped oscillation remains same, external agency is required. This type of oscillation which is driven by external source is called forced oscillation. Abhinav, any doubt?
Sir.
Now in this part, we have two different body. One is the bob, which is oscillating, and the other is the tuning fork, oscillator or external agency. So these two have different frequency. So at a particular instant, when frequency of these two oscillating body becomes equal to each other, that frequency is called a resonance frequency. And at this point, amplitude of vibrating will be maximum. So next, if frequency of oscillating body becomes equal to source, it is called resonance frequency. And this frequency amplitude of oscillating body becomes maximum. Just write it down. Yusuf, any doubt?
No, sir.
Yusuf, done?
1 minute, sir.
Okay.
Done, sir.
So this is all about this entire chapter, oscillation. Next, the last chapter of your syllabus is wave. So let me define you. First, what do you mean by wave? Suppose you have any stone, and if you throw this particular stone from one point to another, during this throwing, this stone must carry some of energy and momentum from this point to reach at this point. So this is one way of transferring energy and momentum from one point to another, in which body themselves moves from one point to another, carrying energy and momentum. But suppose if there is string and if you hit at any one end, let's say at this point, so this hit may create a disturbance at this point, which propagates along the string like this. So in this part, particle of string, this point vibrating along this way, up and down, to create a disturbance which propagates along the string without the displacement of matter particle from one point to another point. So this is another way of transferring energy and momentum from one point to another, in which there is no displacement of matter particle. So this particular phenomena of transfer energy is called wave. Atif, is it clear?
Yes.
So we may define the phenomena of transfer of energy and momentum from one point to another without displacement of matter particle. So this is called wave. Now we may divide this particular wave into three different parts. First is electromagnetic. Second is matter wave, and third is mechanical wave. So in first part, electromagnetic, a wave which does not require any medium for its propagation and it can travel even through vacuum is called electromagnetic. No need of medium for its propagation. Matter wave, a wave which is associated with matter particle such as electron, proton, deuteron, which is defined by de Broglie hypothesis. And you must have learned about it in chapter 2 in chemistry. So matter wave is wave associated with matter particle, that is electron, proton, neutron. And third one, mechanical wave, a wave which require any medium for their propagation, which requires any medium for its propagation is called mechanical wave. Riba, any doubt?
No, sir.
Okay, just write it down. Yusuf, done?
They're writing the points.
Okay.
Done, sir.
Hab, you may take a screenshot. Done? Okay. Now, in this chapter, we have to define only mechanical wave. So first question will be, what would be the property of medium for propagation of mechanical wave through it? So first is property of medium for propagation of mechanical wave through it. So first property is it should offer elastic behavior. So first, medium should be elastic in nature. So I defined you in mechanical properties of solid. Mainly, we have three different types of elasticity. First is Young's modulus, second is shear modulus, and third one is bulk modulus. Young's modulus, shear modulus, bulk modulus, in which these two terms define for shape of body, so it will define only for solids. But this particular part, bulk modulus, which is also called compressibility or depends upon compressibility, so it will define for all medium. Next, medium should be inertial. It means it should have some mass on the base of which it will have tendency to store energy. Suppose in case of vacuum, which is massless, so we can say it will be non-inertial. So mechanical wave will not propagate through it. Is it clear? Abhinav, any doubt? Next, medium should offer minimum or least opposition to the flow of mechanical wave through it. So it should offer minimum opposition. So these are three main properties related to propagation of mechanical wave through any medium. Just write it down. Yusuf, done?
Last 2 points, sir. Sir, can you read the second last point?
Medium should be inertial.
Thank you, sir. Done, sir.
Next, we have to define types of mechanical wave. Suppose you have any soft spring like this. If you hit this particular spring along this direction, so the spring will acquire a shape like this. Like this. So in this part, this region is region of high density. Which is called compression. This part is region of low density. It is called rarefaction. So in this part, there is formation of compression and rarefaction. So due to this, particle will tend to vibrate along this direction. And also disturbance created by it propagate along this direction. So this is vibration of particle. And this is propagation of wave. And both are parallel to each other. Hence, it is called longitudinal wave. Suppose in second part, if a jerk is given at this point, so wave will be created like this. Like this. So in this part, this is highest point, which is also called crest or heels. This is lowest point, which is called trough or valley. So in this part, there is formation of crest and trough. So particle will be vibrating up and down and propagation of wave or propagation of disturbance will be along this direction. These two are perpendicular to each other. So this is vibration of particle and this is propagation of wave. Abhinav, in and out?
No, sir.
So this is called transverse wave. So mechanical wave is of two types on the basis of vibration of particle. First is longitudinal wave, in which there is formation of compression and rarefaction, and vibration of particle will be parallel to the propagation of wave. In second part, transverse wave, there is formation of crust and trough, and vibration of particle will be perpendicular to propagation of wave. That is called transverse wave. Atif, any doubt?
No, sir.
Okay, just write it down.
Sir, can you scroll up? I had some technical problems.
This part,
Yes, sir. No, sir, scroll down the property of medium that.
okay.
Okay, sir, thank you. Can scroll down. Are we all done? Yusuf?
Last diagram, sir.
Okay.
Done, sir.
Now we have to define these two waves individually and in detail. So first is transverse wave. You will say a wave in which particle vibrates perpendicular to the direction of propagation of wave is called transverse wave. Next, we have to define velocity of transverse wave. Velocity of transverse wave. So to define this, let me define you the concept of dimension analysis, and then to derive this part, consider velocity of transverse wave on string depends upon tension T and linear mass density mu. Now, according to concept of dimension analysis, first we have velocity, the quantity which is depending upon, and its dependent factor. First is tension, and the second thing is linear mass density. So from this part, we can say, according to the concept of dimension analysis, velocity equals to some proportionality constant K, tension raised to X, and linear mass density raised to Y. Now, write the dimension formula of each term towards left and right side. So for velocity in left side, it will be m0, L1, and t to the power -1. In right hand side, we have K, which is dimensionally constant. So there will be no any unit related to this part, so just neglect it. T is tension, which having same dimension as compared to force. So it will be ml t raised to -2 exponential x. Mu, linear mass density, that is mass divided by its length to the power y. Now, if you further simplify it, m raised to x from first part and m raised to y from the second one. So it will be m raised to x plus y. Similarly for L, it will be x minus y, and then for t, it will be just minus of 2x. Now, according to the concept of dimension analysis, just compare the exponent on either side for same term. So on comparing the exponent, first for mass, we have m raised to x plus y in right hand side, but in left hand side, we have 0. So x plus y will be 0. The second one for length, we have x minus y equals to 1. And third part for t, we have minus of 2x, which must be equals to -1. So on solving this, we can say x will be just 1 by 2. If you put this in first part, you will get y is minus of x, that is minus 1 by 2. And the value of proportionality constant is 1. So on putting all these values, v equals to 1, t raised to x, which is 1 by 2, mu raised to y, that is minus 1 by 2. So bring this mu downwards so that its exponential will become positive. So will be equals to t divided by mu, having common exponential 1 by 2. So it will be just root under t by mu. So this will be our final formula of velocity of transverse wave traveling on a string. Riba, in it out. Okay, just write it down. Yusuf, done?
No, sir, writing.
Okay. Rehab, in it out.
No, sir.
Okay.
Done, sir.
Suppose from any support, a string is connected and a block of mass 4 kg is attached at this point. Let's say this point is A and point B. Now, a transverse wave is created at A. If linear mass density of wire is 1 gram per centimeter, then find first tension in string, second velocity of transverse wave, created on it, and third time taken by wave to travel from A to B if AB is 50 centimeter. So let me define you how to solve. First, Abhinav, just tell me, what is the source of tension in this particular part? Atif? Which factor in this part is responsible to generate tension in this string AB? Riba? You'll say it is the block which is attached to any one end. So force due to gravity will be acting along this way, which will straighten this particular wire. So a tension will develop into it. So first, source of tension will be mass times gravity. So we have mass, take the gravity to be 10, so you'll get tension in the string. Next, mu, which is linear mass density, which is given 1 gram per centimeter. So first we have to convert it into kg per meter. 1 gram is 10 to the power minus 3 kg, and 1 centimeter is 10 to the power minus 2 meter. So it will be 0.1 kg per meter. Now we have tension and mu. So using it, we may find velocity of transverse wave created as T by mu. Now, on calculating this velocity, next we have to calculate time taken by it to move along A to B. So time taken to travel equals to distance by speed of wave at that point. Distance of AB is given 50 centimeter. So convert it to meter, and speed you will calculate from the second part. put it and simplify it. Yusuf, any doubt?
No, sir.
Okay, try to solve. Aisha, you got any answer? We have tension, which is mass times gravity. Mass is 4 and gravity is 10. So you will get 40 Newton. Abhinav, is it clear?
Yes, sir.
Now put this in this part. So tension we have 40 and linear mass density we have 0.1 root under. So if you remove this decimal, then multiplied by 10 in numerator. So you'll get 400 root under. So it will be 20 meter per second. Now in third part, distance of A to B is 50 centimeter. That is 0.5. Divide by speed 20. So to remove this decimal, 10. So it will be 5 by 2. That is 2.5 into 10 to the power minus 2 second. Atif, in it out? Okay. Rishan, in it out? Have you all done?
Yes, sir.
Okay. In this part, that is transverse wave, which depends upon elastic factor of solid or elastic factor of shape of body. and elasticity in shape is defined only for solids. So you can say transverse wave can travel only through solid. Since transverse wave depends upon elasticity in shape of body, which is defined only for solids. Hence, transverse wave can travel through solids only. Diba, any doubt?
No, sir.
Okay. Next is longitudinal wave. We can say a wave in which vibration of particle will be parallel to propagation of wave. That is called longitudinal wave. So we have to calculate velocity of longitudinal wave. First, write it down to this part. Yusuf, done?
1 minute, sir.
Okay.
Done, sir.
Next, to define velocity of longitudinal wave, consider velocity of longitudinal wave depends upon bulk modulus beta and volumetric mass density, that is rho. So using the concept of dimension analysis, we can write velocity equals to some proportionality constant k beta to the power x rho to the power y. Write the dimension of each part towards left and right. So we have left side velocity. So it will be m0 L1 t to the power -1. And right side, we have k, which is dimensionless quantity. So it will be neglected. Beta, which having same dimension as pressure. So it will be ml-1 t-2 raised to x. Rho, mass per unit volume to the power y. So we may write m raised to x from this part and y from the second one. Length to the power -x and -3y and t raised to -2x. So on comparing the exponent on either side, we can say x plus y equals to 0, exponent of m minus x minus 3y equals to 1 for L, and minus of 2x equals to -1, that is for t. So x will be equals to 1/2 from this part. Put it in first equation, you will get y equals to -x, that is -1/2. And experimentally, value of k is just 1. So on putting these values, velocity will be equals to k beta to the power x and rho to the power y. So we may write beta divided by rho and having common power 1/2, which is also called square root. So velocity of longitudinal wave will be beta divided by rho. Atif, is it clear?
Yes.
In this part, beta is also called elastic factor. And this rho, which is mass depending factor, so it is called inertial factor. So we can say velocity is also equals to root under elastic factor by inertial factor. Yusuf, any doubt?
No, sir.
Okay, just write it down.
Scroll down, sir.
Yusuf, done?
Yes, sir.
Okay. Now this longitudinal wave is basically sound wave. So related to this part, we have to transform this particular relation. So first assumption is based on Newton's formula. So first is Newton's formula. He assumed that propagation of sound in any particular medium will be isothermal in nature. So let me calculate related to isothermal part. He assumed that propagation of sound isothermal. So at constant temperature, PV equals to constant. So we have to calculate beta related to this process. So differentiate with respect to volume. So we have two quantity in product. So differentiation of first term multiplied by second plus differentiation of second term multiplied by first equals to constant term in right hand side. So its differentiation will be 0. So dP by dV equals to minus of P by V for this part. Now we have to calculate bulk modulus. So bulk modulus equals to minus of dP by dV multiplied by V. So if you put the value of dP by dV from this part, minus and minus will cancel out. P by V multiplied by V. So it will be just P. It means bulk modulus for isothermal process will be equal to pressure of system. I defined this particular part also in thermodynamics. Is it clear? Now, related to this part, if you put this in the above formula, so velocity of sound will be beta divided by rho. That will be equals to pressure divided by rho for this part. Now, we have to calculate first for air. Pressure will be 1 atm. That is about 1.013 into 10 raised to 5 Pascal. And density of air is 1.293 kg per meter cube. So if you put these two values in the above part, So velocity will be about 280 meter per second. But in actual, speed of sound in air is about 331 meter per second. So we can say this particular numerical value is very small as compared to that of actual value. Hence, Newton's fail here. So from this part, we can say, but actual speed of sound is 331 meter per second. So he failed. Just write it down. Then I'm defining the correct form of this particular velocity. Yusuf, Dan,
1 minute, sir.
Abhinav, any doubt?
No, sir.
Okay.
Done, sir.
Now to correct it, let me define you another scientist, Laplace correction to the above formula of velocity of sound. He assumed that propagation of sound or longitudinal wave is adiabatic in nature. Why adiabatic? In thermodynamics, I define you what would be the main reason for isothermal and adiabatic. Atif, Have you remembered? How you'll choose a process is adiabatic or isothermal? Riba? If a process is occurring very fast, all of a sudden, that is termed as adiabatic. Suppose bursting of balloon, tire, and if a process is carried out very slow, almost it will behave as rest. That will be isothermal. So in this part, for propagation of sound, there is a formation of compression and rarefaction, which is very fast. So there will be no enough time for exchange of heat. So we can say this propagation should be adiabatic in nature. Atif, is it clear? So you'll say, since formation of compression and rarefaction for propagation of sound is very fast. So it will be adiabatic. Now for adiabatic process, equation of state will be Pv to the power gamma equals to constant. So differentiating with respect to volume, differentiation of first term multiplied by second plus differentiation of second multiplied by first equals to, and right hand side we have some constant term, so its differentiation will be 0. So dp by dv multiplied by v to the power gamma equals to minus of gamma v to the power gamma divided by v multiplied by p. So v to the power gamma, v to the power gamma will cancel out. So you're left with dp by dv equals to minus of gamma by v. So using this, we may define bulk modulus related to this process. Beta equals to minus of dp by dv multiplied by v. So dp by dv is gamma times p by v multiplied by v. So v and v will cancel out. So bulk modulus in adiabatic process will be gamma times p. Aisha, any doubt? Okay, just write it down till this part. Yusuf, done?
Sir, what's after delta Q?
Delta Q equals to 0.
Okay, sir.
Means there is no supply or ejection of heat into system or out of system.
Done, sir.
Now, using this expression, velocity equals to root under beta by rho, where beta we have gamma times p by rho. Now for air, pressure is 1 atm, that is 1.013 into 10 to the power 5 Pascal. Density of air is 1.293 kg per meter cube. And next we have to define gamma. You must have learned about composition of air in outer atmosphere. Abhinav, do you have any idea which is the most abundant gas in outer atmosphere?
Nitrogen.
Good. The next most abundant is? Good. What would be the percentage composition?
%70 oxygen, no, 70% nitrogen.
Nitrogen is about 78% and oxygen about 21 or 20%. So if you combine them together, it will be about 98 or 99% of just two gas. Nitrogen behaves as diatomic and oxygen also diatomic. So we can consider the entire atmosphere to be composition of diatomic gas. Is it clear? So for
Yes, sir.
diatomic, degree of freedom will be 5, and so gamma will be 7 by 5, that is 1.4. So if you put these terms to the above expression, you will get velocity about 331 meter per second. That is approx equals to actual speed of sound in air at this particular condition. Is it clear?
Yes, sir.
So from this part, you'll be asked, define longitudinal wave, derive Newton's formula, and hence explain Laplace correction to it. This will be the entire question related to. Now, next question would be, on what factor velocity of sound may depend upon? So you may write this expression as velocity equals to root under beta by rho, which is equals to gamma times p by rho, which is equals to gamma p. Rho is mass by volume. So it will be m by v root under PV is equals to nRT, so it will be gamma times nRT divided by M root under. So related to these different formula, we may define its various depending factor. So next is factors affecting velocity of sound. First is pressure. From this relation, you will say velocity is directly proportional to under root of P. Is it clear? This is velocity and this is pressure. So these two are related directly proportional to root under. But in actual, there is some different relation. Let me define you. Whenever you have to define dependency of velocity with pressure, just check, is there any temperature dependency or not? So first, if temperature is constant, and second, if temperature is not constant, it means isothermal process or non-isothermal process. So in first part for isothermal process, which is PV equals to constant, we may write volume equals to mass by density equals to constant. So mass will be always constant. Just move it to right side. So you're left with P divided by rho equals to another constant. So from this part, we can say velocity is equals to gamma times P by rho. Gamma is constant and P by rho at this process is constant. So we can say velocity is independent of pressure. Atif, is it clear?
Yes, sir.
So in first part, velocity is independent of pressure if temperature is constant. But if temperature is not constant, then velocity will be directly proportional to P and also inversely proportional to rho. Rehab, any doubt?
No, sir.
Okay. Just write it down, then I'm defining the rest part. Have you all done?
Yes, sir.
Yes, sir.
Okay. Yusuf, done?
Yes, sir. Done.
Okay. Next, dependency for air. Let's say moist air and dry air. So first question will be, which density will be more, density of moist air or dry air?
Dry air.
Good. So density of dry air is greater than density of moist air. And as velocity is inversely proportional to density, so velocity of moist air or velocity of sound in moist air will be greater as compared to dry air. Next dependency will be related to temperature. So you will say velocity is directly proportional to root under T. So these are certain dependency on which velocity of sound may depend upon. Now let me define you questions related to this part. Just write it down.
Please scroll up 1 second.
Up to this part, furthermore,
No, sir, just this part.
yes, Riba, done?
Done, sir.
Okay. Find ratio of velocity of sound in oxygen and hydrogen at same temperature. Just use velocity equals to gamma times nRT divided by m, where gamma is ratio of specific heat and m is its molecular mass. Put their values and divide it. You'll get your answer. Let me give you a hint. We have oxygen, which exists as diatomic molecule, and hydrogen, which also exists as diatomic molecule. So gamma for oxygen will be equal to gamma for hydrogen. So these two terms will also cancel out. So you're left with only one part, velocity of oxygen divided by velocity of sound in hydrogen equals to only mass dependent. So mass of hydrogen divided by mass of oxygen. Just put their values and simplify it. Just the whole term will get cancelled out. Good, Atif. Mass of hydrogen is 2 and mass of oxygen molecule will be 32 root under. So it will be 1 by 16 root under, that is 1 by 4. Yusuf, is it clear?
Yes, sir.
Okay. Similarly, there will be a question like, find temperature at which velocity of sound in helium equals to velocity of sound in oxygen at 7 to 7 degrees Celsius. Just use the above formula and try to find. In this part, we have helium, which is monoatomic, and oxygen, which is diatomic. So gamma for helium will be 1 plus 2 by 3, that is 5 by 3. But gamma for oxygen will be 7 by 5. Convert this particular temperature in Kelvin and just equate their velocity. So velocity of helium to its left side. So it will be gamma. Helium, number of moles R and T. Molecular mass of helium, root under, must be equals to gamma for oxygen and R. Temperature is 7 to 7. Just convert it in Kelvin, you will get 1000. Divide by its mass, root under. Just simplify to find T. Riba, any doubt? Riba, you got any answer? Atif?
Yes, sir.
Just send me. Yes, Abhinav? First, on squaring both sides, this root and root will cancel out. So gamma of helium, which is monoatomic, is 5 pi 3. N and R will cancel out on both sides. T we have to calculate, divide by mass 4 equals to gamma of oxygen 7 by 5 multiplied by 1000 divided by its mass 32. So T will be equals to 7 into 3 into 4,000 divided by 5 into 5 into 32. 4 in 8 times will be 32. 5 and 5, 25. And 4 times will be 100. 8 into 5 times will be 40. So 7 into 3, 21. Into 5, that is 105. So it will be about 105 Kelvin. At this temperature, velocity of sound in helium will be equal to velocity of sound in oxygen at 1000 Kelvin. Aisha, is it clear?
Yes, sir.
Atif, you got this result or something else?
No, sir, I got something inside. Felt like there's a mistake, that's why.
Okay. Rehab, any doubt?
No, sir.
Have you all done?
Yes, sir.
Yusuf?
Yes, sir.
Okay. So this is the first part of this particular chapter wave. We have just finished it. In next class, we will start with new topic, that is traveling wave or stationary wave. Okay. So let's stop here for today. Thank you.
Thank you, sir. Have a good night.
Thank you, sir. Bye,
Thank you,
sir.
sir.